We wanted to see if there was any difference between the body types of people and their ability to metabolize sugar. There are 3 different body types. There are ectomorphs, mesomorphs, and endomorphs. Different body types require different training methods and diet plans in order to stay fit and healthy. Our project's purpose was to question whether a certain body type would affect the percent change of a person's blood glucose level. Our dependent variable was the percent change in blood sugar level of the blood. Our independent variables were the weight when the subject was greater or equal to 134 pounds versus less than 134 pounds, and the height when the subject was greater than 5'6" versus less than 5'6". We collected 20 volunteers from Walter Payton and placed 5 in each category. We collected permission slips so we could prick them with a blood glucose monitor. We had to swab each volunteer's middle finger on the left hand before each prick test with alcohol for sterilization purposes. We made sure to prick the middle finger on the side and towards the tip of the finger. For every blood drawing, we used a new lancet. We pricked each subject and fed them a Hershey bar. Each subject waited 30 minutes before being pricked again in a stabilized room. During the 30 minutes, each subject had to remain seated because any extra movement would have counted as exercise. However, throughout the experiment, there were several potential forms of bias. We bought chocolate bars that were prepackaged, thus the grams of Hershey bar consumed might not have been the same for all participants. Also, since we had to wait 30 minutes before retaking the blood sugar level of each participant, each person might have been digesting the sugar for slightly longer or slightly lower than 30 minutes. Also, through laughing, breathing, or tapping of the foot could have caused a faster metabolism since it can count as exercise. Our first null hypothesis is the true mean of percent change in blood sugar for people who are over or equal to 134 pounds is equal to the true mean of percent change in the blood sugar for people who are less than 134 pounds. Our first alternative hypothesis is our null hypothesis is not true. Our second null hypothesis is the true mean and percent change in the blood sugar for people who are over or equal to 5 feet 6 inches in height is equal to the true mean and percent change in the blood sugar for people who are less than 5 feet 6 inches in height. Our second alternative hypothesis is our null hypothesis is not true. Our third null hypothesis is there is no interaction between the percent change in the blood sugar level of people based on their height and weight. Our third alternative hypothesis is there is an interaction between the percent change in the blood sugar level of people based on their height and weight. Since our p-value of 0.1126 is less than 0.05, we fail to reject our null hypothesis and conclude that it appears there is not enough evidence to state that the mean percentage of change in the blood sugar of people with differing heights is not the same. Since our p-value of 0.6597 is less than 0.05, we fail to reject our null hypothesis and conclude that it appears there is not enough evidence to state that the mean percent change in the blood sugar of people with differing weights is not the same. Since our p-value of 0.2497 is less than 0.05, we fail to reject the null hypothesis and conclude there is not enough evidence to state that there is an interaction between the percent change in the blood sugar level of people based on their height and weight. Based on the results of the study, we conclude that there is not enough evidence that suggests that the mean percent change of blood glucose level with differing weights is the same, as well as with differing heights. We proved our results through a two-way ANOVA test that also showed that there is no interaction between the percent change in blood glucose level with weight and height. Although we did test our subjects in a stabilized environment, we could not account for the different amounts of exercise that each subject can still do even while remaining seated. Breathing, laughing, and movements of the upper body played a role in the differing percent changes of blood glucose level of all the subjects. For future studies, we could expand by testing whether race and gender play a role in the percent change of blood glucose level. We found it interesting that there was no interaction between height and weight, and we would like to find out if there is an interaction between gender and race.